So in the last video, we looked at the difference between a prime and composite number. So today we're going to take that information and apply it to prime factorization. Now, prime factorization is something that comes very useful when we move into greatest common factor and least common multiple. So that's why we're going to learn this part today. And we're going to look at something called a factor tree, prime factorization tree or a factor tree. A lot of it is used interchangeable, but prime factorization, every number has a unique prime factorization. And so that's what we're going to look at. And in fact, to kind of teach it is the best way is just to look at it and see it in practice. So I'm going to start with a number that we can use very quickly and easily just to see the prime factorization of that. And I'm going to do 45. Now, let's review real quick. Prime numbers are numbers like 2, 3, 5, 7, 11, 13, 17, 19. They only have two factors, 1 and themselves. Composite numbers have more than two factors. So numbers like 4, where you can divide 4 by 1 and 4 by 2 and 4 by 4, it has more factors. So we're looking for numbers like 3, 5, 7, 11, 13, 17, 19, 23. Those are some of the main ones that we'll notice here at the beginning. So we start with 45, and I'm just going to make a tree, branches. We're going to go down almost like a Christmas tree, sort of. And I'm going to think to myself, what are two numbers that I can divide 45 by? Now, you can't use 1. Don't use 1. That one's out. But any other factors. So I may think, and I'll go, well, I remember that 5 times 9 gives me 45. Now, when you do this, stop and go, are either of these prime? 5. Well, the only thing that will go into 5 is 1 times 5. So you know what? This is prime. So I'm going to circle it because that tells me to stop. And then I'm going to go over here to 9. Well, I can multiply 9 by 3 times 3 and 9 times 1. So you know what? It's not prime. I can keep going. So I'm going to break it down. Well, what can I multiply 9 by? 3 and 3. 3 is prime. 3 is prime. So my prime factorization for 45, and this is how it will be written, is 3 times 3 times 5. And this is unique for 45 because if I multiplied this back out, 3 times 5 would give me 45. This is the prime factorization. It will only work for 45. It's very unique for 45. No other number has this prime factorization. But notice, all of the numbers are prime. There are no composite numbers. Okay? They must all be prime. And all I'm doing is breaking it down into factors. Prime factors specifically. That's all you can use. Prime factors. No composite numbers. I can't say that enough. No composite numbers. Alright? So let's look and try a couple more. Just the main thing is examples, and then you'll get a chance to try this as well. So let's try 60. Make my tree. What can I multiply to get 60? Well, there's lots of things. It really doesn't matter how you start. If you want to go with 2 and 30, 4 and 15, 6 and 10, you take your pick. So I'm just going to use 6 and 10. That's the first one that came to my mind. And I look and I go, okay, 6. Can I multiply anything to get 6? Is it prime? Well, it's even. And even numbers are not prime, except for 2. And 2 is always prime. All other even numbers, never prime. So I know that I can multiply something to get me 6. And it's 2 and 3. And those are prime. Those are my important ones that I need to remember. So I'm done over here. I come back over here. What can I multiply to give me 10? I can multiply 5, and I can multiply 2. And those are prime. So now I put them in order, and I always order them from least to greatest. So 2 times 2 times 3 times 5. And if you multiply this back out, 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. That is the prime factorization for 60. We broke it down into a unique prime factorization that will only work for the number 60. Okay, let's try a larger one. 150. Well, the fact that it ends in a 0 tells me right off the bat that I can use 10 and 15. Now 10 is not prime, so I can keep going to 5 and 2, and that is prime. 15. Now a lot of people will look at numbers like 15 and 9 and they go, oh, they're odd, must be prime. Don't do that. 15 is not prime because I can do 5 times 3. Break it down. There we go. So now I write it in order. 2 times 3 times 5 times 5. And that is 150. And you know what? You can always check your answer to know if you're right, because this over here should always equal this over here. It's that easy. This should equal this. And if it doesn't, you've messed up somewhere. Now, it's possible, and I've seen this happen before, where people over here have like 6 times 5 times 5 equals 150. Now, I agree that this and this equal, but what I don't agree with is that this is not all prime. This is wrong. That's not a prime number. It cannot be the prime factorization if one of the numbers is composite. All the numbers must be prime. Okay? Now it is your turn. I'm going to give you 3 examples that I want you to do. I want you to do example 1, and I want you to break down 50. Example 2, I want you to break down 90. And example 3, I want you to break down 180. 180. Okay, those are your 3, and then tomorrow we'll work on this a little bit more and see how you're doing on this, and we'll go from there. So I will see you then.